Hi boys and girls, it's time to go over our DMA Math Week 31 Day 1 solutions for your problems. So let's get started. We're going to start off with our first problem, which is a time problem. So if you notice here, it starts us off by saying Victor is going on a trip at 3:15. He needs 30 minutes to pack. What time does Victor need to start packing so that he will be able and be ready to leave at 3:15? So start is one of those clue words to help us understand that we're looking for the start time and not the end time. So if we take what we know about our problem, we know that we are going to, I've already started a timeline here, we know that we are going to need to leave at 3:15. So if we start taking our time and subtracting in 10-minute intervals, the first interval of 10 would place us at, and we're taking 10 minutes from here, would put us at 3:05. The next 10-minute interval, if we subtract 10 minutes from the 3:05, we can subtract 5 minutes, which would put us at 3 o'clock, and then we could subtract another 5 minutes, which would place us at 2:55. Now we can go ahead and subtract another 10 minutes, and this is the 10-minute mark, or the 10 minutes place. And if we do that, we're going to subtract 10 minutes from the 50, and we're going to say 2:45. And probably this is going to be a PM, since a lot of people don't usually leave in the middle of the night or in the middle of the morning hours. There's another way we could also think about this. We could think about it in 15-minute intervals. So I'm going to go ahead and draw same timeline, using the same, of course, ending time, what time he has to leave. But this time, now I'm going to subtract 15-minute intervals. So I would need two 15-minute intervals to make 30 minutes. So if I subtract two 15-minute intervals, if I subtract 15 minutes, here's the 15 minutes right here. That would place the time at 3 o'clock. Then if I subtract another 15-minute interval, that would place my time at 2:45. So either way, this is going to give us the same start time, we're just doing it in a different way. You could also count back by fives, which would mean that we'd have 6 jumps or 6 intervals of 5 minutes, and it still should take us to the 2:45 mark. Okay, so now let's go on to finding the solutions to our multiplication and division equations. So you will notice here we have 9 groups of 8. So I can think of this as breaking this down as a 4 and a 4. And if I did that, I could do 9 times 4, or 9 groups of 4, and 9 groups of 4 again. So if we know our multiplication facts, 9 groups of 4 gives us 36, and 9 groups of 4 gives us 36. And if we add those together, 30 and 30 is 60, and 6 and 6 makes 12. So that would give us 72 as our product. Now, we could also count by eighths if we wanted to do that as well. We could start off with 8, 16, 24, 32, 40, 48. Moving on, we have 56, 64, and finally 72. And there would be our 9 groups of 8. So either way, you're still going to get a product using the factor of 9 and 8 to make 72. Now, our division equation says we're going to take 16 objects and put them into two groups. So if we have our two groups and we don't know our multiplication facts, we could use our understanding of breaking apart this 16 objects into these two groups. And once we take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We will see that we have 8 objects in each group. So that would give us our quotient. Now remember, we can always use our understanding of multiplication to check. So if we have 8 groups, or 2 groups of 8, we can use that understanding to say, okay, well, if I know I have 2 groups of 8, 2 groups of 8 makes my total 16. So we're using our understanding of multiplication to check our equation for our division. This being our dividend, our divisor, and our quotient. Now let's look at, we have 2 groups of 5. So 5 and 5 would make 10 as our product. So our factor, first factor tells us our groups, second factor tells us how many is in each group. Total objects is going to be our product. Okay, let's go on. Since we're working so far on multiplication and division facts, let's go ahead and go to our fourth problem. And it says complete the related, notice it says related, not equivalent, multiplication facts. So using our understanding of division, we have 24 divided by 4. So we could use, we want to know how many groups of 4 does it take to make 24. So we already know this is going to be 24, but we need to know how many groups of that 4. So we could use our understanding of repeated addition, or we could use our understanding of patterns. So we have 4, 8, 12, 16, 20, and finally 24. We count how many groups, 5, 6. That gives us our missing factor. We can do the same thing for 49 divided by 7. We want to know how many groups of 7 it would take to make 49. So again, if we use our understanding of patterns and counting by 7s or multiples of 7, we use our multiples of 7. We could start with 7, 14, 21, 28, 35, 42, and finally 49. Once we get to 49, we count how many multiples of 9 it took, and that would give us 7 groups of 9. And finally, 16 divided by 8. This would be fairly easy because we know that it only takes 2 groups of 8 to make 16. So 8 groups of 2 or 2 groups of 8 would give us our missing factor of 16. Now let's go on to our word problem. So we have a word problem here, and our word problem says Henry has 3 baskets of apples and each basket holds 2 apples. How many apples are there in all? So this is a fairly simple multiplication. We have 3 baskets, those are the groups. We know that each basket is going to hold 2 apples. So if we're going to use our understanding of modeling, we can take that understanding to find out how many apples in all. So we're looking for apples in all. So we can write this out as part of our solution. We have blank apples in all. And that's what we're looking for. And if we have 3 baskets, we're going to use a bar diagram. Here's our 3 baskets. We're going to put 2 apples in each of the baskets for our bar diagram. Then that would give us our total apples. So this is basically what we're looking for. How many apples are there in all? So we have 3 groups. These are the baskets. We are going to take those 3 groups and place 2 apples each basket. And that would give us our total apples for all the baskets, or in total. So we could say before we found our total, we could actually use a letter to say, okay, A is for apples. So we would say 3 times 2 equals A. And so now we can come up here and show that we have 6 apples total. And now we can say apples in all. So we have 6 apples in all because 3 groups with 2 in each group will make 6 total. Total apples. And those are our solutions for today. So see you again tomorrow for week 31, day 2 solutions. Have a great day.